Okay, so today we're going to, hello everyone, thanks for tuning in. Today our goal is to know how to express an algebraic statement in simplest form with a prime number base. So let's work through the answers together. Remember to have a go at each question and then pause the video, play the video to see the answer and check and correct it as we go. All right, so what's the definition of a prime number? Well, it's a number that has two factors. In other words, one and itself. One and itself. Sorry, I've lost my pen today, so I'm going to have to go with the finger on the screen. All right, so what are the first 10 prime numbers? Well, 2 is a prime number because it's only divisible by 1 and 2. 3 is a prime number. 5, 7, not 9 because that's divisible by 3, not 10, but 11. 11 is a prime number. 13 is a prime number. Where are we up to? 1, 2, 3, 4, 5, 6. 17 is a prime number. 19 is a prime number. 1, 2, 3, 4, 5, 6, 7, 8. What have we then got? 23 and 29 would be a prime number. So it's only divisible by 1 and 29. Okay, so we need to know what prime numbers are to be able to do the topic today. So our goal is to be able to express things in simplest form with a prime number base. That means the base before the power is a prime number, like one of these numbers up here. Right, the first one's been done for us. Have a look at what's happened here. 121, that's not a prime number, but 121 is 11 squared. All right, so we've written that as 11 squared. This next one, 27. Now, we were doing these in the worksheet the other day. 27, can we write that with one of these prime numbers? 2 to the power of something? No, it's not going to be 2 to the power of something. 3 to the power of something? Ah, yes. It's 3 to the power of 3, because 3 times 3 times 3 is 27. Nice. 81. Can we write that as 2 to the power of something? You could test it out by just having a go on your calculator. 2 times 2 times 2. No, it's 3 to the power of, well, it's 3 times 3 times 3 times 3, which is 3 to the power of 4. All right, 4 squared. 4 squared. 4 is not a prime number, but 4 we can write as 2 squared, can't we? So 4 is 2 squared, and now the 4 is 2 squared, all squared. We know that we go 2 to the power of 2 times 2 using our index laws. So that's 2 to the power of 4. Happy days. All right, 25 squared. 25, is 25 a prime number? No, it's not. But can we write 25 as one of these times something else? Yes, we can write it as 5. So 25 is 5 squared, isn't it? Right. And if we've got 5 to the power of 2 all squared, that's going to be 5 to the power of 4. We just times those two together. 5 to the power of 4. All right, 9 cubed. 9 cubed. Let's change color just for fun. Let's go to green. 9, is 9 a prime number? No, but can we write 9 as one of these? Squared or cubed or to the power of 4? 3. 9 we can write as 3 squared. And remember there was the 3 there originally. So we can now write this as 3 to the power of 2 times 3. So it's 3 to the power of 6. Right, our last one. Remember to be pausing these and watching as you go and having a go yourself. 4 to the power of 4. What can we write 4 to the power of 4 as? Well, 4 is 2 squared to the power of 4. And 2 to the power of 2 times 4, that's going to be 2 to the power of 2 times 4. So that's going to be 2 to the power of 8. Happy days. Done. All right, next page. Express in simplest form with a prime number base. The first has been done for us. Let's have a look at what's happened here. 2 to the power of x times 2. Well, 2 we can write as 2 to the power of 1, and then using the index laws, we can write them as 1 base, 2 to the power of x plus 1. All right, let's have a go at B. 7, that's a prime number, but 49 is not a prime number. Can we write 49 as a prime number? Yes, we can write it as 7 squared. So it's 7 to the power of t times 7 squared. Now using our index laws, we can add those two together. 7 to the power of t plus 2. Nice. Question C. 3 to the power of a, that's in a prime number base, but 9 is not a prime number. So this means 3 to the power of a divided by 9 we can write as 3 squared. And what's our index law when we are dividing? We subtract, that's right. 3 to the power of a take 2. Great job. This next one, 8 to the power of p divided by 4. Let's change colours to red here. 8. Can we write 8 as with a prime number base? Yes. 8 we can write as 2 times 2 times 2. 2 times 2 is 4. Times by 2 is 8. So that's 2 to the power of 3 p. Now 4, can we write 4 with a prime number base? Yes. 4 is 2 squared. So here we've got 2 to the power of 3p divided by 2 to the power of 2. And when we divide, we subtract the powers. So that's 2 to the power of 3p minus 2. Excellent. Time for the next question. 7 to the power of n over 7 to the power of n take 2. Well, they're dividing and they've got a prime number base already. So we're going to go 7 to the power of n minus n take 2. So that's going to be 7 to the power of n take n. Now minus 2 is plus 2. Remember that minus applies to both things. So it's going to cancel those out. So we're going to be left with 7 squared. And we just leave it as that because it's asking for us with a prime number base. F. 9 is 3 squared over 3 to the power of x, which is 3 to the power of 2 take x. 25 we can write as 5 squared times to the power of t, but that's all to the power of 2. So then we just times these all together. 5 to the power of 2 times t times 2, which is 5 to the power of 4t. Next one. 16 and 2. Let's write these both as powers of 2 because looking back at our prime number list at the top of the page, these we can both write as powers of 2. We want them to both be the same powers. 16 is 2 times 2 times 2 times 2. So it's 2 to the power of 4 to the power of k minus 3 times 2 to the power of negative k. Let's expand this out. That would be 4 bracket k minus 3 times 2 to the power of negative k. Then we expand this out. 4k take 12 times 2 to the power of negative k. And then we both have powers of bases of 2, prime number bases, and we're timesing, so that means we add 2 to the power of 4k take 12 take k. So that equals 2 to the power of 3k minus 12. Happy days. Next question. Let's fly through these on here. So 4 is 2 squared and we've already got a base of 2. So that's 2 to the power of 2a over 2 to the power of b equals 2 to the power of 2a minus b, because it's dividing. This one, 8 and 16, let's do them as powers of 2 because we want them as prime number bases. 2 to the power of 3x over 2 to the power of 4 times y equals 2 to the power of 3x over 2 to the power of 4y. And because we're dividing, we subtract. 3x take 4y. And our last two, 125 and 5. Let's make these powers of 5. 125 is 5 times 5 times 5. So that's 5 to the power of 3 times x plus 1 over 5 to the power of x take 1. Then we'd expand out the top. Then we would subtract because we're dividing. Then we'd collect like terms. 3x take x is 2x, and 3 minus 1 is plus 4. Because plus 4, because you've got the minus and minus 1. So that means add. All right, last one. I'm going to have to clear this to do the last question. Oops. That didn't work. Let's just make some room here. There we go. Just clearing that off so I've got some room here. All right, very last question. All right, 27. These are all we're going to have to put as powers of 3. 27 is 3 to the power of 3 times a plus 2 over 3 to the power of a. Now 9 to the power of a we can write as 3 squared times a, so it's going to be 3 to the power of 2a. Just done that in one step there. Now we expand out the top, 3 to the power of 3a plus 6, 3 all over. Now the base, let's add these together because we've got timesing on the base. Okay. Just clear some room here. So now we've got 3 to the power of 3a plus 6 minus a plus 2a is 3a. So now we collect like terms. 3a, take away 3a is nothing, so it's just 3 to the power of 6. Happy days. Thanks for tuning in. Thanks for watching. And I hope you've learned something about simplifying with a prime number base. Catch you next time.